Hello everyone, welcome to the course and thank you for considering globaletraining.com for your learning. Here is the course outline. We will start with SSH history and a quick demo. Next, we will look at connecting to a remote Linux machine from a Linux machine, a Windows machine, and also a Mac. Next, we will look at running commands on the remote machine and transferring files to and from the remote machine. Next, we will look at the process of connecting to a machine that is behind a jump box. Next, we will look at the port tunneling, also known as port forwarding. Next, we will look at connecting to a remote machine using keys, which is common in the real world. In the last part of the course, we will look at some advanced topics covering SSH server installation and setup, securing SSH server, SSH command options, and SSH client configuration. Well, that's a long list. Okay, by the end of this course, you will become very comfortable using SSH and become an advanced SSH user. In today's market, Linux administrators and DevOps engineers are expected to work with SSH on a daily basis. So this course is a perfect course for you. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will discuss the prerequisites for this course. We expect the student to have some basic Windows and Linux OS skills. Command line. You don't have to be an expert at the Linux command line, but being familiar with the Linux command line will help you better follow this course. Access to machines. Having access to physical or virtual machines to practice SSH would enhance your learning exponentially. We will use 2 physical machines and multiple virtual machines during the demos. OS/software. We will use various flavors of Linux OS, Windows 10, VirtualBox, PuTTY, and FileZilla during this course. In the next video, we will look at the lab setup. Hello everyone, welcome back. Let us take a quick look at the lab setup used throughout this course. We used Oracle VirtualBox to create and host the virtual machines that are part of the lab setup. Here is a network diagram that represents our lab. We have 7 virtual machines that we created using Oracle VirtualBox. The 4 VMs on the left are connected in bridge mode, which uses 192.168.10.x IP schema. The blue VMs on the right are connected to the network in NAT mode. 172.16.1x IP schema is used on the NAT network. The gray VM in the middle is connected to the bridge network and also to the NAT network using 2 network cards. All these VMs are hosted on a physical machine running Windows 10 and Oracle VirtualBox. The jump box in the middle acts like a middleman. Say we are on 192.168.10.11 machine and we need to connect to a VM on the NAT network. We will need to first SSH into the jump box using the IP address 192.168.10.25, and then from there we should be able to SSH into the nodes on the NAT network. This kind of setup is very common in the real world because this allows the IT administrators to control access to certain systems. If you are unfamiliar with a VirtualBox setup, then we would highly recommend you to enroll into our course, Mastering VirtualBox and Network Virtualization. Please see the bonus section for the coupon. Okay, let us now jump into the history and a quick demo. Hello everyone, welcome back. Before we dive deep into SSH, let us clearly understand what this SSH is. So, what is a secure shell? It is a software that allows users to connect to remote systems and the communication is encrypted. On the flip side, the telnet communicates using clear text. It is very easy to sniff a telnet session to extract information. The name secure shell confuses many beginners. They might think it is something similar to a Unix shell like bash or KSH. Secure shell is not a Unix shell. Then, what is a secure shell? To start, SSH is a protocol. The SSH protocol specifies details on how to establish a secure communication over the network. You can refer to internet resources for SSH specifications. The SSH protocol talks about the authentication, encryption, and integrity for establishing remote sessions. The term SSH refers to different things based on the context. Also the case SSH versus lowercase ssh. SSH generally refers to SSH protocol, products, and clients. SSH1 refers to SSH protocol version 1. SSH2 refers to SSH protocol version 2. The lowercase ssh represents a client software. SAP and PuTTY are other client softwares that are developed based on the SSH protocol specifications. OpenSSH is an open source product from OpenBSD. Here is a small list of SSH implementations which are commonly heard in the industry: PuTTY, OpenSSH, WinSCP, CyberDuck for Mac, Tectia SSH. Tectia SSH is from SSH Communications Security Inc., which provides commercial support. So, who is this SSH Communications Security Inc.? What is the link between this company and the SSH? To understand that, let us look at the history in the next video. Hello everyone, welcome back. I know students generally want to get hands-on and don't care about the history, and I am no exception. Knowing little history helps. Secure Shell was developed by Tatu Lonen in 1995, and I'm sure I have pronounced the name incorrectly. Anyways, in July 1995, the open source version of the Secure Shell was released. The developer worked with Internet Engineering Task Force for standardization of Secure Shell. Later, SFTP was developed by the author of SSH. SFTP stands for Secure File Transfer Protocol. In December 1995, Tatu Lonen started SSH Communications Inc. SSH protocol replaced many protocols like Telnet, FTP, and or login. And I'm done talking about the history. I am sure you'll find a lot of internet resources for those interested. Let us jump into a quick demo in the next video. See you there. Hello everyone, welcome back. We will look at a quick demo in this video. Here is the VirtualBox and the virtual machines. We will SSH from VM node 1 to VM node 2 in this video. The virtual machines are already running. Here is VM node 1 with the IP address 192.168.10.11. Here is the VM node 2 with the IP address 192.168.10.12. Let us SSH from VM node 1 into VM node 2. Enter lowercase ssh followed by the IP address of the target machine and hit enter. Since we are connecting for the first time, we get this message. Enter S and hit the enter key. As you can see here, we are connecting as the user training. This is because we did not specify the username and the SSH used the logged in username as a username to connect to the target machine. In our case, this will not cause an issue because we have a user account training on the target machine as well. To connect as a specific user, you can use the syntax username at the host name or the IP address. Enter the password and hit the enter key. Let us make sure we are connected to the target machine. Let us create a folder called sample1 on the target machine directly, and here is a sample1 on the ls-l output. Let us switch to VM node 1 and run ls command. Here is a sample1 folder. Run the hostname command. VM2 is the hostname of the target machine. Let us run the fconfig command. As you can see, the IP is 192.168.10.12. Exit out of the SSH session using the exit command. Run the hostname and ipconfig commands to confirm that we are back on VM node 1. And it looks good. In this demo, we SSH'd from a Ubuntu machine to another Ubuntu machine, and as you have seen, it was very simple and easy. Well, that's it in this video. See you in the next. Hello everyone, welcome back. In this section, we will look at the following. Connecting to a remote Linux machine from a Linux machine, from a Windows machine using PuTTY, and also from a Mac machine. We'll also look at running commands on the remote Linux machine and running a local script on the remote machine. Okay, let us jump into the section. See you there. Hello everyone, welcome back. In this video, we will SSH into a remote Linux machine from a Windows machine. Here is our VirtualBox lab environment. Here is a Linux VM that we will SSH into. The IP address is 192.168.10.12 and the host name of the machine is VM node 2. Here is a Windows VM we will use. The IP address of the Windows machine is 192.168.10.14. Let us try SSH command. Well, we don't have it. PuTTY is a de facto tool that is used from a Windows machine to a Linux machine. I mean to say, to SSH from a Windows machine to a Linux machine. Here is the putty.exe. You can Google it and download it for free. Here is the PuTTY interface. Let us create a connection profile for 192.168.10.12. Now use the Open button to open a session to 192.168.10.12. Since we are connecting for the first time and our Windows machine does not recognize the fingerprint of the Linux machine, we are prompted with this message. Click the S button. You will see a SSH terminal with the login prompt. Enter credentials to log in. Let us check the host name and the IP address. It looks good. Okay, all you need is to download the PuTTY software and connect to your desired Linux machine as long as network is in place and you have credentials for it. For in-depth learning of PuTTY software with great real-world tips, we encourage you to join our PuTTY course using the discount coupon in the bonus section. Okay, that's it in this video. See you in the next. Hello everyone, welcome back. In this video, we will SSH into a remote Linux machine from a Linux machine. Most of the Linux distros come with SSH client tools installed. Here is our VirtualBox lab environment. And here are the two Linux machines we will work with. 192.168.10.12 with the host name as VM node 2 and 192.168.10.11 with the host name as VM node 1. From this machine, let us SSH to 192.168.10.12. Enter SSH followed by the IP address 192.168.10.12 and hit enter. Since we are connecting for the first time to the .12 node from the .11, we are prompted with this message. Enter S and hit the enter key. The machine will save the fingerprint of 192.168.10.12 and you should not see this prompt for the subsequent logins. Enter the password and we are in. Let us check the host name. Looks good. As you have seen, it's very simple. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will SSH into a remote Linux machine from a Mac machine. Open a terminal and enter
SSH followed by training at 192.168.10.12 and then hit the enter key. Enter the password and we are in. Looks good. As you have seen, it is very simple using Mac as well. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will run commands on a remote machine using SSH. We will use VM Node 1 and VM Node 2 virtual machines. We will run commands on VM Node 2 from VM Node 1. Here is the VM Node 2 and let us run the ifconfig command. The IP is 192.168.10.12. We have a file called messages.txt on this machine. I mean to say message.txt. Let us display the contents. Here is our VM Node 1 and the IP address is 192.168.10.11. Let us run the ls command to make sure that we don't have the message.txt file on this machine, which is VM Node 1. Now let us SSH to 192.168.10.12. As you can see, the PS prompt of the node is VM Node 2. Exit out of it. Now run the SSH command with a different syntax. At the end, enter hostname. By the way, hostname is the command that displays the hostname of the computer. SSH followed by training at 192.168.10.12 space hostname. Hit the enter key. Now enter the password. It displayed VM Node 2 and we are back at the prompt of the VM Node 1 machine. What really happened here is that the SSH program ran the hostname command on the remote machine and displayed the output and closed the SSH session. It's simple. Next, run the cat command on home training message.txt on VM Node 1. We are actually using the full path. No such file. And that is because the file is on VM Node 2 and not on VM Node 1. So now enter the SSH command followed by the cat command to display the file, by connecting to the .12 node. So enter SSH followed by training at 192.168.10.12 space cat space /home/training/message.txt. Enter the password. The SSH command displayed the contents of the file message.txt and closed the session. As you have seen, running a command on a remote machine via SSH is simple. However, the program or file you are trying to access must be present on the remote machine and you need to have appropriate permissions. Well, that's it in this video. We will look at running a local script on a remote machine in the next video. Okay, see you there. Hello everyone, welcome back. In this video, we will run a local script on a remote machine using SSH. We will use VM Node 1 and VM Node 2 virtual machines. We will run a script called machine-info.sh on VM Node 2 that is located on VM Node 1. Let us run the ls command, and here is the machine-info.sh script. Let us run it. The script displayed the host name and the IP address of the machine. Let us run the host name and the ifconfig commands to verify the script output. Now let us run the ls command on the VM node 2 machine, and we don't have machine-info.sh file. Let us run the SSH command to run the machine-info.sh script. Enter the password. SSH displayed an error and closed the session. This is because the script is not on VM node 2 machine. We need to stream the script to the remote machine using the SSH command and run it on the remote machine. And here is the syntax for that. We are running bash with S option and passing the local script as the input. Enter the password, and here is the output. As you can see, the host name is VM node 2 and the IP address is 192.168.10.12 on the output, which is the remote machine. Let us look at the script. And here is the SSH command. As you have seen, running a script on a remote machine via SSH is also simple. Well, that's it in this video. See you in the next. Hello everyone, welcome back. In this video, we will connect to a remote SSH server that is running at a non-default port. By the way, port 22 is a default SSH port. So far, we haven't specified the port 22 while connecting to a SSH machine. That is because if the server is listening or running at the default port 22, the client is not required to specify port 22 because the client by default uses port 22. Okay, we will use VM node 1 and VM node 2 virtual machines in this video. Let us quickly check the host name and the IP addresses of the VMs. Now, let us SSH to 192.168.10.12 from 192.168.10.11. And we will use the command SSH space training at 192.168.10.12. We received connection refused error. What really happened is that by default SSH client tries to connect to port 22 on the SSH server, and in our case the server is not listening at port 22, and that's the reason why we are seeing connection refused error. The SSH server is listening at port 2222. I know that because I changed it. Now let us use the port 2222. So enter SSH followed by training at 192.168.10.12 space -p space 2222. Enter the password. Oops, let me retype the password. Okay, we are in now. Let us switch to a Windows virtual machine and connect to 192.168.10.12 using PuTTY. We have an existing profile for 192.168.10.12, and as you can see, the profile is configured to connect to port 22. Click Open to connect to 192.168.10.12 using the existing profile. Here is the same error we saw before, connection refused, which was pretty much expected. Now let us go back to PuTTY and update the port number to 2222 and then try to connect. Wow, much better this time. Click S, enter the credentials. Okay, we are in on the third attempt. Well, in this video, we looked at connecting to a SSH machine that is running with a non-standard port from a Linux machine and also from a Windows machine using PuTTY. Well, that's it in this video. See you in the next. Hello everyone, welcome back. Here is a quick introduction to this section on file transfer using SAP and SFTP. We will look at the SCP command and then look at a GUI client called FileZilla, which is also used to copy files and directories. We will conclude this section with some real-world tips. SCP stands for Secure Copy. SCP command comes with the SSH tool set. No additional software is required. SFTP stands for Secure File Transfer. We will look at the free tool FileZilla, which implements SFTP protocol. Downloading and installing FileZilla is very simple. Well, let's jump into the section. Hello everyone, welcome back. We will look at the SCP command to copy files to a remote machine and copy files from a remote machine. We will use VM node 1 and VM node 2. Here is the VM node 1. Let me open one more terminal and SSH into 192.168.10.12, that is VM node 2. So now we should be able to work with both the machines with this arrangement. Let me change the profile to white on black to help ourselves visually working with these tabs. Let me quickly check the host name and the IP address. Both the VMs look good. On 192.168.10.11, we will work with the folders projects-vmnode1 and temp_from_vmnode2. Projects-vmnode1 folder contains 2 files and 2 folders. On 192.168.10.12, we will work with the folders project-vmnode2 and temp from vmnode1. Projects-vmnode1 folder contains 2 files and a folder. Temp from vmnode1 folder is empty. Let us switch to 192.168.10.11 and copy a file to the other node, which is 192.168.10.12 machine. On 192.168.10.11, enter this command: SCP followed by projects.vmnode1.txt space the target machine IP, which is .12://home/training/temp_from_vmnode1. So what we have here is SCP followed by what you are wanting to transfer, and then the target machine's IP address or host name, followed by the whole path where you want to copy it. Now enter the password, and the file is transferred, and you can see the output of the SCP command. You can also pass the absolute path for the local file with the SCP command. Let us verify the file on 192.168.10.12 machine. Looks good. Let me remove the file on this .12 machine. Now let me switch to .11 and transfer multiple files using while character. Here is the SCP command that we used. Instead of specifying the name of a specific file, I will use *.txt to match all files ending in .txt. As you can see, 2 files ending in .txt were transferred. Let us verify. Now, being on 192.168.10.11, let us get the files located on .12 machine. That means we are copying files from the remote machine to the local machine. With SCP command, we pass the source location and then the destination location. In other words, first pass from info and then to info. Since we want to get the files from the remote machine, we need to first pass the remote machine as the source. So the command would be like this. The dot at the end represents the present location on the local machine. Well, here is the file. Let me remove the file. This time we will get all files that end in .txt. We will use the while character as before. We got 2 files. Let us execute the same command with $home instead of the dot. This will copy the files to the home directory of the local user on this machine. Done. Let us verify now. Looks good. Well, that's it in this video. We looked at the SCP command usage to copy files to a remote machine and copy files from a remote machine. See you in the next video. Hello everyone, welcome back. We will look at the scp command to copy files and folders recursively in this video. We will use VM node 1 and VM node 2. Let us try to copy the folder httpd 2.4.33 to 192.168.10.12. Pay attention to the source and destinations. Well, that did not work because httpd 2.4.33 is a folder and not a file. Let me try without a slash. Well, that did not work as well. Since it is a folder, we need to use the recursive option R. It is a lowercase r. Looks good. The command transferred bunch of files. Let us check on 192.168.10.12 machine. Okay, here is the httpd folder. Let us remove the folder and transfer one more time with a slight change. For the source, we will add a slash followed by an asterisk. This would match all files inside the folder, which means the command would transfer the contents of the httpd folder and not the folder itself. It's done. Let us verify. We don't have the httpd folder, but we do see bunch of files here now. Depending on your need, transfer the folder and its contents or just the contents. Now we will copy the files and folders from 192.168.10.12 by running the commands on 192.168.10.11 node. All we need to do is swap the source and destination locations when compared with the previous scp command. We can also use tilde to represent the home directory. Looks good. Well, that's it in this video. We looked at copying files and folders recursively to a remote machine and also from a remote machine, and you have an option whether to transfer the folder and its contents or just the contents. So depending on your need, you need to use the command appropriately.
Well, that's it. See you in the next video. Hello everyone, welcome back. Here is a quick introduction to the section on using key pair. We'll first understand the concept of the public and private key, and then discuss the files associated with the keys. And then we will look at generating the keys on Linux, Windows 10 and Mac systems and using them. Take it slow with this section if this is your first time working with key pairs. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will understand the concept of the public-private key, also known as key pair. Here is an analogy. Padlock and key. We need a key that is specific to the padlock to open it. A different key will not work. Let us say we manufactured 5 identical padlocks. We can use the same key to open any padlock. Let us now discuss in terms of public and private key. Here is our padlock and its associated key. Padlock will be similar to public key in our discussion, and the key would be the private key. So, when computers are involved, we would send our public key to all our desired machines. The computers would encrypt anything that they send us using the public key, and we will use our private key to decrypt it. Well, that's how key pair works in a nutshell. Please watch this video one more time if things are not 100% clear. See you in the next video. Hello everyone, welcome back. In this video, we will look at the key pair setup overview for SSH. First, we will generate RSA key pair, then copy the public key to the target machines. Here, we assume that the target machine has SSH installed and is running. Next, we will SSH to the target machine using these keys. Here is the concept with visual aids. On the left, we have 2 machines, and the user of these machines wants to SSH into the web server on the right using the keys. First, we will generate key pair on both the machines. Then, we need to copy the public key from the Linux machine to the web server. Next, copy the public key from the Mac machine to the web server. Once the public keys are copied over, the user should be able to SSH into the web server without any password prompt. Well, that's a quick overview of the setup. In the next video, we will look at generating the keys on a Linux machine. See you there. Hello everyone, welcome back. In this video, we will generate the public key and the private key on a Linux machine and use them to connect to a remote Linux machine. We will use VM node 1 and VM node 2, and by now you must be familiar with the IPs. They are 192.168.10.11 and .12. Here is our VM node 1 machine, and I just ran
machine-info.sh script to display the host name and the IP address. Let me open one more terminal and establish a SSH session to 192.168.10.12 so that we can work with both the machines. I mean VM node 1 and VM node 2. Okay, we have a SSH session open to VM node 2. Let me change the profile to black on white so it helps us visually identify both the sessions. I mean the local session, which is VM node 1, and a SSH session to VM node 2. Let me quickly run the machine-info.sh script on the VM node 2 just to verify the host name and the IP address. Okay, now we are all set with this terminal so that we can work with both the machines. Let us switch back to VM node 1. Now let us cd into the .ssh folder. The .ssh folder on the client machine holds the public key private key that we create and also a file called known host. Anytime you establish a SSH session to some remote machine, a fingerprint is written to this file, which is known host. SSH-keygen command is used to generate the public and the private key, and by default they are RSA key pair. Now by default the keys are written to a folder called .ssh in your home directory, and the private key is written to id_RSA and the public key is written to id_RSA.pub. Now you do have an option to customize the path, but I would recommend to leave this alone and just accept the defaults. Next, what you see is the passphrase. The passphrase is not your Unix login password. This is the passphrase for your private key, meaning anytime you attempt to use your private key to establish sessions to remote machines, you don't enter the Unix credentials or Unix login credentials, rather you would enter the passphrase. It's entirely up to you. You can assign any password you like here, or you can leave it blank. I mean, for testing purposes, you can just leave it blank. And once you hit enter, it's done in a flash, and as you can see, the public key is written to id_rsa.pub, and the private key, which is also known as your identification, is written to id_rsa. Let me go ahead and list the contents of the .ssh folder. See? So we have id_rsa and id_rsa.pub. And we have already seen the known host a couple of minutes ago. Let me show you the contents of these files, the public key and the private key. Look at the last portion of your public key. It has your login ID at the host name, which is training at vmnode1. Now, what is the procedure for the setup? We have seen that in our previous video, or maybe the one before, that we need to actually copy the public key to the remote machine or your target machine. So the one that you're looking at, which is id_rsa.pub, the contents of this file need to be copied to our remote machine, which is vmnode2. Okay, let me switch to the node vmnode2 and cd into .ssh folder within the home directory. Let me list the contents. There's nothing in there, and we need a file called authorized keys. I mean to say authorized underscore keys, and this is where the public key goes. What I'll do is I'll just VI the file, which is authorized underscore keys, and just copy the public key from VM node 1 into this particular file. Okay, I have copy pasted the public key, and now what I'll do is I will just save the file and change the permissions to 400 using the chmod command. Now let me open one more terminal, which would be obviously VM node 1, and using this terminal we will SSH into 192.168.10.12. As you can see, we were able to SSH into VM node 2 without any password prompt. This is because we have the public key of VM node 1. It's really the user's public key was copied to the VM node 2. Well, that's it in this video. It's very simple. If this is your first time trying to understand this public and private key concepts, I would recommend you to watch this video one more time so the concepts are clear. Okay, see you in the next video.
Hello everyone, welcome back. In this video, we will look at generating key pair on a Windows machine. Here is our VirtualBox environment, and we will use VM node 2, which is 192.168.10.12, and there is a Windows VM with the IP address 192.168.10.14. Let me RDP into the Windows virtual machine with the IP address ending in .14. Here is the RDP session, and we have a PuTTY shortcut on the desktop. Let me go ahead and double click it. Here is the PuTTY interface, and we already have a profile 192.168.10.12. Let me load it just to make sure the IP address is correct, and we'll open a session. Here is our terminal. Let's go ahead and enter the credentials to get in. Okay, we are in. We cannot generate the public and private key using the PuTTY software. We need to download an additional tool. By the way, it is provided by the same website where you download the PuTTY from. We need to download it and use it to generate the key pair. So let me open a browser and go to putty.org. Click the very first link shown on the screen to get to the PuTTY download page. Here is the download page, and scroll down a little bit to locate puttygen.exe. Click on it to download the software. And now locate pagent.exe and download it as well. Here is the pagent and puttygen that I just downloaded. I will create shortcuts to both these tools on my desktop. Now let me open puttygen to create the key pair. Here is the PuTTY key generator interface, and click on the generate button, and then start moving your mouse as shown in the video. Randomly move it so the tool itself generates based on your key movements, generates the public key and the private key. Once it is done, this is what you would see on your screen. Optionally, you can assign
a key passphrase, which is not your Unix login password, by the way. This is the passphrase in order to use your private key. And you'll see that here in a few minutes. Click the Save Private Key button to save your private key to your file. Give it a name as per your preference and hit the Save button. Now you're back on the PuTTY key generator interface, and you have the public key in the small window here at the top. You can copy it and paste it to your file, then give it some name based on your preference. You also have an option to save the public key using the same public key button on the interface. Click the button and you'll have a Save As dialog box. Give it some name, a preferable name, and save the public key. So let me open both the public key files so you can see how the key is saved into the file, when we save it manually versus when we use the Save Public Key button. Now the next step is to copy the public key to the Linux machine. So let me copy the public key so that I can paste it into appropriate file on the remote Linux machine. Now let us switch to the SSH session that we opened before and go into .ssh directory in the home directory. This is where authorized_keys file is located. Open the file using the VIA editor so that we can paste the public key into the file. Paste the public key and save the file. Now let us switch back to the Windows machine and open our PuTTY. We will load our 192.168.10.12 profile and configure it to use the public key. After you load the profile, on the left hand side, navigate to Connection, SSH, and then click on Auth. And on the right hand side, there is a Browse button that can be used to browse to the private key file. Once you select the private key file, make sure you go back to the session and save it. If not, the configuration will not be saved. Next, click on the Open button. And once the terminal is open, enter the login ID training. And now what you see is the passphrase. So go ahead and enter that, and boom, we are done. We are inside the machine. The SSH session is open now. As you have seen, all we did was we entered the user ID and it prompted for the passphrase. We keyed that in and we are inside the machine. Now let me close the session and configure our profile to use the user ID training by default. That way we don't have to enter the login ID anymore. Make sure you save your profile. If not, it will not be saved. Now let's open the session. As you can see, the training is by default passed to the session, and it's just prompting us to enter the passphrase. Enter your passphrase and you should be in. So it looks good. We have the default user ID configured within the PuTTY, which is passed to the SSH session, and we already have the public key on the Linux machine, and the PuTTY is configured to use the private key. So all we are doing now is entering the passphrase. Now let us see if we can mitigate this as well, meaning we don't have to enter the passphrase anymore. Now in order to make that happen, we need another tool. This is where pagent comes into picture. Now let us take a look at it. And by the way, it is very simple to use. We already have a shortcut on the desktop. Double click it
and you don't see any interface, it gets loaded and it's in your system tray. Right click on it and click on View Keys. Now you have little interface here which says pagent key list, and if you're using it for the first time, it should look like my screen, meaning it should be blank. There should be no keys. Click the Add Key button and that'll let you browse the private key. Now once you select your private key, it's going to prompt you for your passphrase. Enter the passphrase, and the key gets added to the list, and click the Close button. Now it's done. Let us go ahead and open the pagent one more time to make sure that our key is listed there. And yes, we do have it. Now let us open our PuTTY interface and try to establish or open a session to the .12 node. As you can see, there were no prompts. We are already in. Nothing complicated, just follow the steps, you'll be just fine. Well, thank you. See you in the next video. Hello everyone, welcome back. In this video, we will generate key pair on a Mac OS and configure it to connect to a remote Linux machine using these keys. Well, it should be pretty straightforward and simple, similar to what we did in the last couple of videos. Okay, let us jump in and get the thing started. Here is a Mac machine that we will use, and I have a terminal open. Let me cd into .ssh folder and see if there are any files there. We don't have any files. Let us SSH into 192.168.10.12 from this terminal. Since we are logging in or establishing a SSH session for the first time, we get the prompt. Enter S there, and then we have the prompt to enter the password. Okay, we are in. Now we are inside VM node 2. Let me run the machine-info.sh script real quick. The script displays the host name and the IP address of the machine. Let me open one more terminal and check the contents of the .ssh folder on the Mac machine. This time we see a file called known_host. So when a machine establishes a session for the first time, it creates a file called known_host and it adds an entry into this file. Let me cat the file, and as you can see, the line starts with the IP address of the machine. Now let us move on to generating the key pair. SSH-keygen command is used to generate the public key and the private key. You have an option to save the private key to a custom location or accept the default, which goes into the .ssh folder in the home directory, and the file will be called id_rsa. Hit enter, and now you have an option to enter a passphrase for your private key, and it is optional. You can leave it blank as well. Hit enter and it is done in no time. It literally takes a second to complete the whole process once you hit the final enter. Okay,
Now we have the public key and the private key, and the next step is to take the public key from this Mac machine and copy it to the Linux machine. In our case here, it is the .12. Let us quickly list the contents of the .ssh folder. And here are our public key and the private key. The next step is to copy the public key from the Mac machine to the Linux machine. Now, before we execute the command to send the public key, let us first switch to the vmnode tool and look at authorized keys file. And then after we execute the command, we'll go back and look at the authorized key file again, because we need to actually see the new entry, and we have 2 keys in the file. Now let me switch to the Mac machine and run the command ssh-copy-id and training at 192.168.10.12. Enter the password, and as you can see, the command copied the file. Now let's switch to the Linux machine and quickly check the contents of the authorized _keys file. Well, as you can see, we do have an entry there. The third one, the very last one, is from the Mac machine. As you can see at the very end, it says training at training Mac. So we were able to successfully copy or send the public key from the Mac machine to the Linux machine. By the way, the command is available on the Linux machines as well. Now let us SSH from the Mac machine to the vmnode tool and see if these keys work. Here is the passphrase prompt, and we are in. As you have seen, there is no prompt for the password. Okay, we are done. So in this video, we created a public key and a private key on a Mac machine and copied the public key to the Linux machine using the command, and we did not copy it manually. And then we were able to establish the SSH session using these keys. Well, that's it in this video. I'll see you in the next. Hello everyone, welcome back. In this video, we will install OpenSSH on a Fedora Linux distribution. The installation process for OpenSSH server is very simple. It is available as a package, so you just run the m command to install the OpenSSH software, and then you start the service. That's it. 2 steps. Install and start the service, and you're good to go. So here is our Fedora Linux machine, and we have a terminal open. Let us run the m command. Enter sudo space yum space install space OpenSSH-server and hit enter. Enter the user password and the installation starts. Now we have another prompt. Enter Y and hit enter key, and it should proceed. Installation is done. Now all we have to do is start the service using the command sudo systemctl start sshd. Now let us use the netstat command and grep for 22 to make sure that port 22 is in listen mode. And we have port 22 in the listen mode. Let me go ahead and stop the SSHD service. And then list the port 22 using the netstat command, and it is not listed now. That means it is not in the listen mode. Well, that's it in this video. We installed OpenSSH server on the Fedora machine, and we were able to start the service and look at the port 22 using the netstat command, and we also stopped it. Well, that's it in this video, and I will see you in the next. Hello everyone, welcome back. In this video, we will look at OpenSSH server installation on a CentOS machine. Here is our CentOS virtual machine, and the IP address is 192.168.18.15. Let us run the yum command to install the OpenSSH server. So enter the command sudo yum install OpenSSH, OpenSSH server, OpenSSH clients, OpenSSL libs. Say yes for the prompt and the installation should proceed. The installation is done. As you have seen, it's pretty much straightforward and very simple. It's a matter of executing a command. Now let me run netstat and grep for port 22. I don't see any port 22 listed. Let me start the SSH server using the command sudo systemctl start sshd.service. Now let me run the netstat command and grep for port 22, and now I see it. It's in the listen state. Now let me quickly SSH from another machine. Well, that's done. We are able to SSH, and it was very simple. Okay, in this video, we install the OpenSSH server on a CentOS machine, and we SSH'd into the CentOS machine from another Linux machine after starting the OpenSSH server. Well, that's it in this video. See you in the next. Hello everyone, welcome back. In this video, we will look at OpenSSH installation on a Ubuntu machine. Here are the two VMs we will work with: VM node 1 and VM node 2. Let me try to SSH from VM node 2 to VM node 1. As you can see, we have a connection refused error. Let me go ahead and install the OpenSSH software on the VM node 1 using the command sudo apt get install OpenSSH server. Enter the password, say yes for the prompt, and the installation gets started, and it will be done here in a couple of minutes depending on your internet speed. Let us start the SSH service using the command sudo service SSH start. Let us look at the status real quick using the command sudo service SSH status.
As you can see, it is running. Let us look at the port 22 using netstat command. Now let me switch to the VM node 2 virtual machine and SSH into the .11 node, which is VM node 1. Enter the command ssh space 192.168.10.11. Hit enter. Since we are connecting for the first time, we have the prompt, enter yes and hit the enter key. We are in. So we are done. We install OpenSSH server on one Linux machine, and then we started the service, looked at the status, looked at the port 22 using the netstat command, and then we SSH'd into this node from another node. Well, that's it in this video. I'll see you in the next. Hello everyone, welcome back. In this video, we will look at the jump server. The jump server separates the user from the target host or the target network. In the industry, a jump server is also referred as jump box or bastion server or pivot server. There might be other names used in the industry. Again, it depends on the organization and things like that. But the role of this particular machine, whatever they might refer to, but is to separate the user from the target machine. Here is a quick visual aid to understand the role of the jump server. So, why do we need a jump server? The jump server adds security because it sits in between the user and the target machines. And that makes auditing easy because, any user trying to get into the network will have to go through the jump server. On top of this, you can add more than one jump server to add granular security into your network. Meaning, you could have jump server 1 through which you can access, say for example, just the front-end web servers. And maybe you could have a jump server 2 through which users can access maybe the DNS servers or maybe, some other application servers. Let us recap that with a quick animation. So we have user on the left, and on the right we have 5 machines. 2 of them are red in color and 3 are blue. And we have a jump server 1 which is red and jump server 2 which is blue. So the authorized users, in order to connect to the 2 red servers on the right hand side, will have to go through the jump server 1. And the same user, to access the blue servers on the right, will have to go through the jump server 2. Again, just to keep things simple, I've used colors. Once we have the network properly configured with correct IP schema, the net effect would be that a user sitting on the jump server 1 will only be able to access the red servers on the right hand side, and the user connecting to jump server 2, which is blue, will be able to access just the blue servers and not the red servers. Let us look at some of the real-world usages of the jump server. You can use the jump server in front of your DMZ layer, or you could have it sitting in front of your core network components. You could have it sit in front of your DNS servers, mail server, Active Directory servers, file server, print server, etc. Okay, enough of theoretical concepts. Let us look at a demo in the next video. Hello everyone, welcome back. In this video, we will take a look at a demo where we will access a machine that is behind a jump server. Here is our VirtualBox environment. We have a bridge network and a NAT network. We have a machine called VM Jump Box with the IP address of 192.168.10.25, and the same machine also has a second IP which is 172.16.1.25. This machine will act as a jump server while trying to access the machines that are on the NAT network from the bridge network. And it's the same thing when we are accessing from the NAT. So if you're trying to access a system in the bridge network from the NAT network, you will have to go through this particular jump box. The physical machine is part of the 192.168.10 network. Here is a command prompt from the physical machine, and let me run the ipconfig command. And here is the IP 192.168.10.100. So the bridge network machines are on this particular network, meaning 192.168.10.x network. From the physical machine, let me ping 192.168.10.11. And it works just fine. We are able to ping. Now let me try to ping 192.168.10.25, which is the IP address of the jump box, and we are able to ping. Now let me try to ping 16.1.1.25, which is the second IP of the jump server. And as you can see, we are not able to ping that particular interface. And just for the sake of it, let me go ahead and ping 172.16.1.21, which is the IP of one of the machines on the NAT network. And we are not able to ping that particular IP. Here is the PuTTY interface on my machine. As you can see, I have some of the profiles configured already. Let me try to open a session using the profile 192.168.10.11, which is a machine on the bridge network. And as you can see, we have a login prompt from that particular machine. Next, let me open a session using the profile 192.168.10.25 jump box. And here we go. We have the login prompt. Now let me try to open a session using the profile 172.16.1.25, which is the NAT interface of the jump box. And as you can see, we are not able to connect. Now let me quickly try to connect to 172.16.1.21 IP. And as you can see, we are not able to connect. Let me close all the sessions. Now let us connect to 172.16.1.21, which is a VM on the NAT network, through the jump box whose IP is 192.168.1.25, and it also has an IP of 172.16.1.25. Because we are on the bridge side of the network, we will first SSH into the jump server using the 192 IP of the jump server. And once we are in the jump server, from there we will SSH into 172.16.1.21. Okay, let's do it. As you can see, we were able to SSH into a machine that's on the NAT side from the bridge network by going through the jump box. That's it in this video. I hope you all got a hang of what a jump box is. See you in the next video. Hello everyone, welcome back. In this video, we will introduce you to SSH port forwarding, which is also known as port tunneling. Using SSH, we can establish a secure connection over an untrusted network like internet, and you will be able to transport data over the encrypted session to the target machine. Without much configuration, SSH delivers encryption, confidentiality, integrity, and authentication. And using SSH, you can also open backdoors to the internal network. I mean, it's not a good idea, but you can do that. Let us take a quick look at this using a diagram. We have a client machine on the left and we have an application server on the right. And both these networks, I mean to say systems, are connected using a untrusted network. Say for example, internet. Now, when these machines communicate over an untrusted network, you cannot guarantee the fact that nobody hacks into your data. And this is where the SSH server comes into the picture. It will sit right in front of the application server. Now, the client machine or the client application would first establish a SSH session to the SSH server, and then the client machine will communicate to the application server through the SSH server. Next couple of videos should add more clarity into this concept. Okay, when it comes to SSH port forwarding types, we have local forwarding and remote forwarding. That's it in this video, and I promise you that next two videos will add more clarity into the concept of port forwarding. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will look at local forwarding. Before we jump into the VMs and start, executing some commands, what we will do is we'll step back and take a look at these machines at a very high level with the visual aids and understand the current state, and then understand what we will be achieving by executing certain commands in order to configure local forwarding. We have a client application running on a machine on the left hand side, and then we have the application server, and then we have a SSH server sitting right in the middle, which will act like a jump server. And by the way, you will also have SSH process or the daemon running on the application server as well. Given this scenario, the client machine will be able to map a local port, in this case red, to some port on the SSH server. In this case I have red. And at the same time, the client machine will also be able to map a local port to the application server. By the way, the application server is also running SSH daemon or the SSH process. In this case, I have a yellow color dot connecting to an orange color dot on the application server. All these dots that you see for are the ports, the TCP IP ports. So what is the impact of establishing local forwarding on the client machine? Now on the client, if you try to access, say for example, the red port, the request is directed to the green port on the SSH server. And when you try to communicate with the yellow port on the client machine, the request is forwarded to the orange port on the application server. So with this, let us take a look at one more illustration where you can actually see what it means with the actual applications. Like we will be using web applications and we will be using specific ports, and that will give you a good understanding on what this local forwarding means. So let's take a look at that. Here is the exact same diagram, but I have some IP addresses, some specific ports to give you a good understanding. So the client machine IP is 192.168.10.11, which is on our bridge network within our VirtualBox environment. And the one in the middle, which has the IP addresses ending in .25 and .25, of course, it's 192 network and 172 network. One interface is on the bridge network and the other is on the NAT network. And the one on the right hand side ending in .22, that's a machine on the NAT network, and it has Nginx running at port 80. In the same way, we do have Nginx running on the jump server at port 80 as well. You can see those ports on the diagram. Now the goal is to make these websites appear locally on the client machine, which is .11, as if they were running there locally. So what we would do is we would establish a SSH session from the client machine to the jump box in a way that it opens up or maps port 80 on the jump box to the port 8025 on the .11 machine or the client machine. And what we'll do is we'll map a local port, in this case for example 8022, to port 80 on 172.16.1.22, which is on the NAT network. So when you open up your browser on 192.168.10.11 machine and browse to the local IP address 127.0.0.1 using the port 8025, you would actually see a website coming from the jump box. And when we hit the port 8022, the website comes from our machine 172.16.1.22. I would recommend you to pause for a couple of minutes, digest this diagram, make a mental picture, get a good understanding on what we're trying to achieve here before you proceed. Okay, let's jump into these VMs and start configuring all this. Here is our VirtualBox environment, and here are the three machines we will deal with. One is on the bridge network, one connects to bridge network and the NAT network, which we will call it as a jump box or jump server, and then we have another machine which sits on the NAT network. Here is 192.168.10.11 VM, which is on the bridge network, and let us try to ping the bridge interface of the jump box and NAT interface of the jump box and also a NAT machine and see how it goes. And as you can see, we are able to ping the bridge interface of the jump box, and we are not able to ping any of the NAT interfaces. Let me switch to the jump box. And here are the IPs: 192.168.10.25 and 172.16.1.25. Let me open a browser on this VM and access the local IP. As you can see, we have Nginx running, and we are able to access the Nginx page using both the IP addresses of the jump box. Let me try info.html page. It displays the host name and the IP addresses of the machine. It is just a static information that's being served out of a static HTML page. Now let us switch to the machine on the NAT network with the IP address 172.16.1.22. And we do have Nginx running on this machine, and let us take a look at the page. This machine also has info.html, which displays the hostname IP address of this particular VM. So as you can see, it is VM node 22, and the IP address on the page is 172.16.1.22. Let me access the same page using the loopback IP address, and we are able to. Now let me switch to 192.168.10.11 VM. Let us fire up a browser and try to access the address 192.168.10.25, and then we'll try to access info.html page, and we are able to retrieve the page. Now let us try 172.16.1.22. As you can see, we are not able to access the Nginx running on the NAT machine, which is 172.16.1.22. Now let us try to establish a SSH session to the jump box, and at the same time we'll also perform local forwarding, meaning we will map port 8025, which is local, to the port 80 on 192.168.10.25. So once this command is executed, so we should be able to access the Nginx page using the loopback address on this particular bridge machine, which is 192.168.10.11. So the command is SSH, and you specify -L, L represents for local, and 8025, that's the local port, : the IP address of the SSH server or your target machine. In this case, it is 192.168.10.25, and then we will follow it by port 80, because 80 is the port we want to map to. If it is something else, then you would enter that particular port, and then we would enter the actual IP address of the jump box, which is .25. Hit enter and enter the password. Let me open one more terminal and use netstat command to list the open ports, and let me filter it for 8025. As you can see, now we have port 8025 on the local machine in the listen mode. So let me fire up a browser, and here is 192.168.10.25/info.html page coming directly from that machine. Now let me open up one more tab and try using the local IP address, which is 127.0.0.1 and port 8025/info.html. Wow, that worked. As you can see, we are able to pull the same web page using the loopback IP address 127.0.0.1. Let me switch back to the terminal and close the existing SSH session and reopen another SSH session, but this time we will map two ports, one to the Nginx running on the jump box and another to the Nginx running on the 172.16.1.22 machine. And here is the command. All we did was we added one more mapping to the previous command. As you can see, it is -L 8022, which is local port, to 172.16.1.22 at port 80. As you know, we cannot access that particular node 172.16.1.22 directly from this particular VM. However, when we go through SSH, the SSH server helps you contacting that particular machine, and that's how it works. Now, when we execute this command, we should have two ports in the listen mode on this particular machine, which is .11. Here is the output of the netstat command, and you can see 8022 and 8025 are in fact in the listen mode. As you have seen, we were able to access both the Nginx websites using appropriate port numbers. In this case, we have 8025 mapped to the Nginx on the jump server and 8022 to the Nginx running on the machine that is part of the NAT network with the IP 172.16.1.22. Well guys, that's it in this video. We looked at local forwarding, and we were able to do it successfully to the machine that is directly connected within the bridge network, and we also were able to perform local forwarding with a machine that is part of the NAT network and behind a jump box. It's a matter of executing commands with the right syntax. Well, that's it in this video guys. I'll see you in the next. Hello everyone, welcome back. In this video, we will look at remote port forwarding. Here is the diagram that we looked at with the local forwarding. In the local forwarding demo, we SSH'd from the client machine to the server machine and opened up a port on the client machine that is mapped to a desired port on the server machine. In other words, a new port is opened on the machine where we execute the SSH command. With the remote forwarding, we will not open any port on the client machine where we run the SSH command, but we open it on the machine that we connect to, which would be our target machine. So with the remote forwarding, if I establish a session from the client machine to the server machine, a new port is opened on the server machine. And if I SSH from the server machine to the client machine, a new port gets opened on the client machine. So wherever we are connecting to, that's where a new port is open. Coming back to this diagram, we would create a SSH session from the server machine to the client machine with remote forwarding, and that would map some desired port on the server to a port on the client machine. Of course, that's a desired port as well, but that's a new port that gets opened on the client machine. Now, let us look at our lab environment. The lab environment is exactly the same as what we have used during the local forwarding demo. During local forwarding demo, we ran the SSH command on the client machine, which is 10.11 machine. With the remote forwarding, we would run the SSH commands on the jump server with the IP addresses 192.168.10.25 and 172.16.1.25. And the result is that we would open up new ports on the .11 machine. And in this case, we would open 8090 and 8091. 8090 gets mapped to the Nginx port on the jump server, which is .25. And then we would create port 8091 on the .11 machine, and it's mapped to the Nginx port on 172.16.1.22. And the secret sauce for this is that all we have to do is use the R option for mapping. And here is the syntax. Okay, let us jump into our VirtualBox environment. As mentioned a minute ago, we would be using 3 virtual machines during this demo. Here is the VM node 1 with the IP address of 192.168.10.11, and let us access the Nginx on 10.25 machine. Looks good. Let us run the netstat command on this machine and grep for 8090 port, and we don't have any. We are back on the jump box, and let us open a SSH session to 192.168.10.11 machine using this particular command. It is SSH space -R 8090:192.168.10.25:80 followed by 192.168.10.11. So here what we are doing is we are connecting to the machine 192.168.10.11 and we are opening up a port 8090 on the remote machine, which is .11, and mapping it back to where we are connecting from, in this case .25, to the port 80. Hit enter and enter the password. We are in. Now let us switch to the VM node 1 and run the netstat command and look for the port 8090. And here we have the port 8090 in the listen mode. Now let us open a browser on this machine and go to the loopback address and use the port 8090. And we should see the Nginx page from the jump server, because the way we established the session, the port 8090 is mapped to the Nginx port on the jump box. And looks like it is working. We do see the page from the jump box. Let me switch back to the jump box and exit the SSH session. Now let me switch to the VM node 1 and clear the browser cache and access the same URL 127.0.0.1:8090. As you can see, we are not able to access the Nginx page. Let's quickly run the netstat command. And as you can see, the port 8090 is not in the listen mode. It is in the time wait. Now let me switch to the jump box, and this time when we establish a SSH session to the VM node 1, we would create two ports on the VM node 1, and one would be mapping to the Nginx on the jump box and the other would be mapped to the Nginx on 172.168.1.22. And here is the command. All we did was we added a new mapping with the R option. In this case, we said 8091:172.16.1.22:80. Let me quickly switch to the VM node 1 and run the netstat command and filter for 8090 and 8091 just to take a look at it. We don't have any. Okay, let's switch back to the jump box and run the command. We are in, and let us switch to the VM node 1 and see if we can find those two ports. It appears like the netstat command is not listing any ports. Let me take a look at it. Okay, I see a syntax error. Let me fix it and run the command again. That looks much better. As you can see on the screen, we have port 8090 and 8091 in the listen mode. Now, if we open a browser and go to 127.0.0.1:8090, that should pull the Nginx page from the jump box, and when we browse to 8091 port, that should pull the Nginx page from the 172.16.1.22 machine. Okay, here is the web page with port 8090, and it is pulling the Nginx page from the jump box and looks good. Now let us try to pull the web page for 8091 and let's see what happens. And we are in fact getting the page from the node 172.16.1.22. Let me switch to the jump box and close the SSH session. Now let me switch to VM node 1 and run the netstat command and filter for our ports 8090 and 8091 and see what happens. And as you can see, the ports are in the time wait state and not in the listen state. Let me quickly clear the browser cache and access the same web pages. And as you can see, we are not able to access the Nginx web pages. Okay guys, that's it in this video. And let me summarize what we just did. We established a SSH session from machine A to machine B, and we opened up a port on machine B and mapped it back to a port on machine A where we actually ran the SSH command. I hope the local forwarding and the remote forwarding concepts are clear. If not, please watch these videos one more time and do some hands-on practice to understand these concepts. Hello everyone, welcome back. In this section, we will explore X11 forwarding. We will look at what X11 forwarding is, we will look at X11 servers, and then we will look at Xming, which is one of the X11 servers. We will look at its installation on a Windows machine. After we go through all these concepts, we will have a couple of demos where we will access remote Linux GUIs from a Windows machine and also from a Linux machine. We have utilized X11 videos from our other course, Mastering PuTTY for Beginners. If you're interested in learning PuTTY, please enroll into our course using the coupon provided in the bonus section. As you already know, these courses come with 30-day money-back guarantee. So please enroll, watch the course. If you feel it's not worth or it's not adding value for your skill set, you can always unenroll to get your money back within 30 days. Okay, well, that's it about, the Mastering PuTTY for Beginners course. Let's jump in and, get into our track on X11 forwarding on this SSH course. Well, that's it. See you in the next video. Hello everyone, welcome back. So, what is X11 forwarding? Well, that's the topic of this video. So far, we were using PuTTY to open a terminal session to a remote Linux machine. As you have seen, it was a text-based session. There were no graphics. What if we want to access the GUI application running on the Linux machine? How do we access them? Can we make them appear on the machine where we have PuTTY? This is where X11 forwarding comes to our rescue. To make X11 work, we need a X11 server that can receive and display the Linux GUI. Well, let's look at that. In the next video, we'll look at the available X11 servers in the market, and we will use one of them in the upcoming videos to actually pull the GUI from a Linux machine and display it on the Windows machine where we have PuTTY running. Okay, see you in the next video. Hello everyone, welcome back. Here are some of the X11 servers that are available in the market: Cygwin X, Xwin32, Xseed, Xming. We will use Xming in this course. Let us quickly look at their websites. The links to these websites will be provided in an attachment. Here is the Cygwin website. Here is the Xwin32 website. Here is the Xseed. And here is the Xming X server. That's it in this video. We will look at the Xming installation in the next video. Hello everyone, welcome back. We will look at the Xming installation in this video. Open your favorite browser and go to our friend google.com and search for Xming. Click on the first link, sourceforge.net. Click the green download button to download the Xming software. Locate the downloaded Xming installation file, and it depends on your browser and its settings. Double-click the Xming 69031 setup.exe file. The file name might be different depending on the latest version that is available at the time of your download. Click Yes for the User Access Control prompt. Accept the defaults and click through the installation process. Here is the Xming running, and it is present on the system tray. Here is About window of the Xming. Since the Xming was launched by the installer, let me close it and start it to complete this demo. Use the Windows search to search for Xming. You will see the Xming in the search results. Click it. And now you should see the Xming on the system tray. Well, that's how you start the Xming server. It is running and listening on the network. That's it in this video. In the next video, we will look at the X11 forwarding setting in PuTTY. See you there. Hello everyone, welcome back. In this video, we will look at the X11 forwarding setting in PuTTY. By the way, the configuration is very simple. All we need to know is its location, and then we need to enable it. Here is the PuTTY interface, and we will enable X11 forwarding for VM09 session profile. Let's load the profile, and on the left we will go to Connection, SSH and X11. Now on the right side, we have a checkbox to enable X11 forwarding. Check it, go to Session and save the changes. That's it. As I had mentioned, it's very simple. We will look at X11 forwarding demo in the next video. Hello everyone, welcome back. I know you have been eagerly waiting on to see how this X11 forwarding actually makes the remote Linux GUI appear on the Windows machine. Let's jump into the demo. Here is our PuTTY interface. Let us load VM10 profile and check if the X11 forwarding is enabled before we open the SSH session. Okay, X11 forwarding is enabled. Let us log in now. Let us check if Xming is running, and it is not. Let me quickly start the Xming. Okay, now we have the Xming running. We can now access Linux GUI applications from this Windows PC. Let us access the disk manager on Fedora. The command is gnome disks. Give it few seconds and we should see a window popping up. Well, here it is. That is cool. Let me access the Firefox browser. Okay, we have the Firefox browser. Let me check the version. Then it is 54.0 and it clearly says Firefox for Fedora. Let me open Firefox on this Windows PC and check the version. And it is 57.0.4 version. That is cool. There's nothing more to it. To summarize, all you need is Xming running, enable X11 forwarding, and open a SSH session to access Linux GUI applications. Well, that's it in this video. Hello everyone, welcome back. In this video, we will access Linux GUIs that are running on a remote Linux machine from a Linux machine. During the demo, we will use two Linux machines. The first one is VM node 1 with the IP address of 192.168.10.11 and the second machine, which is VM Jumpbox 1 with the IP address of 192.168.10.25. And here we will display the GUIs from 192.168.10.25 on 192.168.10.11 machine. Here is a desktop environment of .11 node, which is our VM node 1. We already have a terminal open. Let me open another terminal, and from that terminal we will SSH into 192.168.10.25. We are in, and let me try to access a GUI application on .25, and for example we will use xclock, and we have an error. It says cannot open display. So let us go ahead and fix this issue. Let us first close the session and SSH again into the .25 machine, but this time we will use -x option, and the X is capital X. Now let us try xclock again. Well, we are able to pull the application or display the application on this machine, and as you can see in the title bar, it does say on VM Jumpbox in the bracket. Now let me try to open the Firefox browser using the same technique. Well, the Firefox browser is displayed on the screen, and you can see on the title bar we have on VM Jumpbox. That tells where that application came from. If you have not skipped any videos so far in the course, then you must be familiar that we have Nginx running on the Jumpbox. I mean to say the VM Jumpbox. So now that we have the browser from that machine displayed on .11, we should be able to access the Nginx page. And also we'll try to access info.html. So let's do it. As you can see, we have the info.html page, and it clearly says it's 192.168.0, I mean to say 10.25, and 172.16.1.25. These are the IPs coming from, I mean to say the web page coming from the Jumpbox. Let me go ahead and close the browser, and next I will open the Firefox browser from the local machine, which is the .11, and try to access 127.0.0.1 and show to you that we don't have Nginx running on the .11 node. Now let us quickly take a look at how we can disable X11 forwarding from the server configuration. Open the SSH-D configuration file that is located in /etc/ssh folder. And search for X11 forwarding. It must be set to yes, change that to no, as shown, and save the file. And all you need now is to restart the SSH daemon. And the command that is used is sudo service sshd restart. Again, these commands depend on the type of Linux distribution that you use. So let me close the current SSH session and reconnect to the machine, and let's make sure that we use the -x option. And we are in. Now let me try to run xlog command. As you can see, we have an error. It says cannot open display, and this is more because of the fact that we disabled X11 forwarding at the configuration level. Well, that's it in this video. See you in the next. Hello everyone, welcome back. In this section, we will look at securing SSH. In this video, we will have a quick overview of the topics covered in this section. Before we jump into the various settings to secure the SSH, we will first look at all the files that are related to SSH. Okay, let us jump into the section and I will see you in the next video. Hello everyone, welcome back. In this video, we will look at all the configuration files that are related to SSH. Let us first take a look at the system-wide SSH configuration files. These files are located in etc/ssh folder. ssh_config is the system-wide client configuration file. If a user has his or her own configuration file located in his home directory, that would override this system-wide configuration file. The next one, sshd_config, is the configuration file of the SSH daemon. The next two are the host DSA public key and the private key used by the SSHD daemon. The next two are the RSA private key and the public key used by the SSHD daemon. These are used by the SSH protocol version 1. The next set of files are the RSA private key and the RSA public key as well, but these files are used by the SSH protocol version 2. Next, let us take a look at the user-specific SSH configuration files. By the way, these files are located in .ssh folder, which is in the user's home directory. The very first one that is listed is the authorized_keys. This is the file that holds the authorized public keys for the servers. Next, id_dsa and id_dsa.pub are the DSA private key and the public key of the user. Next, id_rsa and id_rsa.pub are the RSA private key and the public key of the user for the SSH version 2. Identity and identity.pub are the RSA private key and public key of the user for the SSH version 1. Known_hosts file contains the host keys of the SSH servers accessed by the user. And the last, config file. This is the user specific SSH client configuration file, and this will override the system-wide file located in /etc/ssh. Don't try to sit and memorize this list of files. By the time you complete the whole section and do some hands-on practice, most of the files should be very familiar to you. SSHD_config versus SSH_config. The only difference between these two names is the D. So D stands for daemon. So SSHD_config is the configuration file for the SSH daemon. The SSH_config is the client configuration file at the system-wide level. Let us take a quick look at some of the configuration files with a small animation. We have SSH client and a SSH server. On the client machine, we have a private key and a public key. By the way, these are RSA keys. And there is a file called known_hosts. And on the server, we have authorized_keys. And this particular file is specific to the user, meaning from the client, if you're connecting to the server as user 1, then this file would be inside the user 1's home directory. In order to establish key-based authentication, we will have to copy the public key from the client machine to the authorized_keys file on the server. When a user establishes the SSH session from the client machine to the server machine for the first time, the server's key is written to the known host file on the client machine, and the file is nothing but, the key is nothing but the server's identity. Let us look at the screenshot of SSH session real quick. The screenshot here tells us that the client machine is trying to connect to the node or the machine 10.12 for the first time. Once the session is established, the server's identity is written to the file known_hosts. That's it in this video. Now that we have a basic understanding of the SSH configuration files both on the server and on the client side, and we also have understanding of these keys, let us get into the security part of the SSH, meaning hardening the SSH itself. Okay, see you in the next video.
Hello everyone, in this module we will look at the SSH commands or SSH tools that come with the SSH package. Before we dive deep into all those tools, we will first try to understand the difference between learning and real-time job. Okay, let us jump in. Learning versus real world. In learning, what happens is all the instructions are provided either in a video format or you might have a document. The lab is completely a controlled environment. You normally have full access and you're dealing with 1 to 10 machines at the most. And to the most part, these machines are not critical. The data is not critical, the network is not critical, the systems are not critical. Just in case if you mess up with these configurations and you make these machines not usable or not accessible, nothing is going to happen. So while you're learning, you're with this particular mindset that you're just learning, nothing happens, and you get to run the commands and you're good to go. However, when you come to the real world, the situation is entirely different. You may be dealing with 1 or 10 or 100 or thousands of machines.
And these machines are classified based on their role: testing, development, staging, DR, production, etc. Depending on the project data and the environment, the data criticality changes. So you have to be very sensitive to these machines. By that, what I mean is, say for example, you are planning on running certain commands on a testing environment by SSHing into the testing machine. If for example, if you do that on a production machine accidentally, then you are in a deep trouble. So you have to be very careful when you're working with remote machines through SSH, on your job. Another thing is, you'll be switching between these environments depending on what you do. So you got to be careful. So number one, you have to be very careful, and there are tools that come handy when dealing with these situations. Now there are a few commands that come along with SSH. There are SSH keygen, SSH scan, SSH copy ID, SSH add, SSH agent. They make your life easy. Well, that's it, and I'll see you in the next video. Hello everyone, welcome back. In this video, we will look at the SSH key scan command. And why do we need that? That's the point of this video. Let's jump in. We will use 4 Linux machines to demonstrate the usage of the SSH key scan command. We are on the very first machine, which is 20.0.0.5, and we'll use the remaining .6, .8 and .9 to SSH into. So let me first check the IP address here. So that's 20.0.0.5. Now let me try to SSH into the .6 machine. And as you can see, we have a message. The authenticity of host 20.0.0.6 cannot be established. This is because I'm trying to SSH into this machine for the first time. And that's not the only reason. If I had already SSH'd into the machine, and technically I shouldn't be getting, however, if the remote machine got reinstalled, or if SSH was completely reinstalled, or you deleted your known host file, you would run into this particular message. Let me cancel out of this, and let me show you something. I'm inside .ssh folder. If you had watched my previous videos, you might have seen that I was talking about the known_host file. That is the file that contains the list of machines that this particular machine has been communicating with in terms of SSH. So there's no file here. Let me SSH now. I'm going to say yes. Now it is done. I don't have to really complete it by entering the password. I can just cancel out and show you that there is this file called known_host. So let's see this file, cat. So we have the public key of that particular machine. Now let me close this. Now, why do we really care about this particular command, the SSH key scan command? The reason is, when you are automating your infrastructure work, and you are trying to get into all these remote machines via SSH, and if for whatever reason your known host file got replaced or got deleted, or the remote machines got reinstalled, or SSH got reinstalled, one of these reasons, you'll be getting those prompts, and you really don't want your scripts to handle all that. You want to suppress all that. You could do using a SSH command itself, but I'll talk about that later. But the purpose of the purpose of this video is to show you how you can scan the machines, get all those public keys. I mean, they're not the public keys of the users, but it is the public key of the machine itself. You will get that into your known host file. That way, when your scripts run, they don't really get prompted to enter yes or no. So let's deal with that now. So the command is, let me show you this one more time. So let me remove this file. Done. Now let me run the command SSH key scan, and the IP address is this 20.0.0.6, and let's see what happens. So what this did is it displayed the public key of the machine, but you see three different public keys. They are in different format. As you can see, this is EC, DSA, and this is RSA1, and this is ED25519. So what this command is doing is it is connecting to that remote machine via SSH, and it's just requesting the public keys. So now what we can do is just repeat that command but direct the output into the known host file. As you know, let me go back for a second. Let me show you that there is no such file. And now let me run this command. So all that will go into that file, known host file. We have all that. Now if we try to SSH into 20.0.0.6, there will be no such prompt. Now it's directly asking you for the password. Now let me go ahead and delete this file, and let me show you something else. Instead of just scanning one, you can actually scan multiple. Instead of one IP, let us enter two IPs. So SSH key scan 20.0.0.6 space 20.0.0.8. Hit enter. As you can see, it does get the public key from both the IPs, but it might be not practical for you to key in all the IPs in a line. So normally you would have a text file. So let me build a file called nodes.txt and enter those IP address here, one per line. Since these are the three machines I'm dealing with, now I have all three names. I mean to say three IP addresses. Let me save the file. As you can see, I have this file nodes.txt with all three IP addresses. Now what I'll do is I'll use the same command SSH key scan, and I'll use -f switch fr file and pass that particular text file nodes.txt. Hit enter. As you can see, it is displaying the public keys from all three machines. You dump 100 IP addresses in there, it will do the same thing. So now what we can do is, let me list the contents, and now we will repeat the same command, but we will direct the output into our known host file. It is done. Let me display the contents. We have all the keys here, and you can see the IP address here at the front. Now I can SSH to any machine, and I should not be getting that prompt. Oops. It's directly asking me for the password. As I had mentioned before, if you had your passwordless configuration set in place, then you would directly get in with no prompts, no password prompt. By the way, this is how you use the SSH key scan command. The command is primarily used to scan the machines for the host public key and get that onto your machine, and you would use the redirector to direct all the contents into your known host file. And if you already have the file, you will append the file by using 2 greater than symbols. By that, what I mean is, instead of using 1 greater than, you would use 2 so that the output gets appended if you have an existing file. Well, that's it in this video. I'll see you in the next. Hello everyone, welcome back. In this video, we will look at the SSH keygen command. We did visit this command in the past, but in this video, we will show you how you can automate it by making this part of a script. That means we will show you how you can suppress all the prompts and pass the password if required, and also point to a desired location. So first, let us take a look at our .ssh folder. And as you can see, we don't have any keys. Let me switch back to my home directory. And now from here, let me run the command. And I'm not going to say anything, RSA algorithm or anything. I'll just run the command and hit enter. And it is, now prompting me. By default, it points to a file called id_rsa inside our .ssh folder, which you already know. I'll accept that, hit enter. For the password, I'll leave it blank, blank, and it's done. Now, if I go to .ssh, I should see those two files, id_rsa and id_rsa.pub. One is the private key, the .pub is the public key. Now, let us try to run the command silently. That means there will be no prompts. Let me run it. You know what? Before I run the command, let me switch to a temp folder called temp keys. This folder is an empty folder. Now here, let me run the command SSH keygen -t RSA. I'll not pass any size, and I'll say password is capital P. I'll keep it blank. You can obviously enter your desired password between the double quotes and then define the file -f, and you can give the file. I'll say my_rsa.key, and it's done. There's no prompt and everything. Let me list the contents. I have both the files. Now, because I just gave the file name, it created in the current working directory. You can also pass full path if you want to create the file at a desired location. By that, what I mean is, instead of saying this, if I do now, the files will be created inside your .ssh folder. Let me do this. Let me create it. It's done. And let me go into that folder. You see those my_rsa2.key. Let me switch back to the temp keys folder, and now let me also show you how you can create a larger key. Say for example, if I do cat my_key, as you can see, that's the size of the contents of this particular file. If you want a bit larger key, I mean to say, by default it is 1024 bits. If I want 4096, which is 4 times that key, all you have to do is pass the option. Let me pull the command and RSA, and I want to say 4096. That's the size, and I'm going to even put some password. In this case, 12345. I'll say hit enter. As you can see, it is taking some time. It almost took like 3 or 4 times the regular command when we did not pass -b 4096. By default, it is 1024. So now let me list the contents. Oh, by the way, it went to the .ssh folder. So let us go in there. So our keys here, as you can see, this is much bigger. So let me list the contents of the file that we originally created, which is my_rsa2. That's the size. And if we do RSA_4096, as you can see, this is a little bigger in size. So if desired, larger the better. So you can create the desired size as well. Well, that's it about this. So as you can see, it is not prompting you. So in terms of scripting, it's pretty easy.
I'll give you a quick demo. So the script, or I mean to say the command was this. So let me change this. By the way, this is going to do that anyway, so I'll switch back to this temp. Then I'll go ahead and copy this whole thing. Copy and create a script, create and paste the command here. I'll call it my score RSA underscore, I'll say a dot key chmod 744. Now if I run the command, I mean to say the script, it creates the files my RSA underscore a dot key. But without those appropriate options within the command, it'll be prompting you, and the script will run into those issues. If you really want to automate, this is how you do it. Well, that's it in this video. So we looked at the SSH keygen command, which we already looked at before, but we revisited the command and kind of demonstrated how you can create different sizes of keys, and also how you can run the command in a silent mode so there are no prompts. So you would define the pathway you want to create and the size, and the algorithm here we use RSA. Well, that's it in this video. I'll see you in the next. Hello everyone, welcome back. In this video, we will look at the SSH copy ID command. Earlier in the course, we created key pairs, nothing but public key and private key, and copied the public key into the target machine so we could log in without a password using these keys. And in this video, we will use a command which will copy the file for you. I mean to say the public key. So let us take a look at it. I'm in the machine 20.0.0.5, and let me try to SSH into the machine 20.0.0.6. As you can see, it is prompting me for the password. Let me list the contents of this .ssh folder, and I already have id underscore RSA and id underscore RSA.pub, and I don't have a password for it. So let me copy the public key to the remote machine. So what I can do is, the command is ssh -copy d and then training it 20.0.0.6. So primarily the public key from this machine, from this account that you're logged into, will go into the remote machine 20.0.0.6 into the user account training. Of course, it will prompt you for the password, and the file has been copied. Now you can test it. Let's go ahead and now try to telnet SSH into 20.0.0.6 and hit enter. Well, now we got in. There was no prompt, nothing. There was no prompt for the password primarily. Now let me quickly demo the same thing with a different Linux machine which uses a different account. So it's SSH copy ID, and we'll do web dev at 20.0.0.8, and that's our account on the target machine. On this local machine, it's training. Hit enter, and it's prompting for the password, and it's copied. Now if I SSH into this machine .8 with that account, there'll be no prompt for the password. I'm in. Now let us look at another example where you would create a totally new private and public key and use that public and private key to log into a different machine, which is .9 in this case. So for this, first let us create a new public and private key. Now that we have my RSA_1.key, that's a private key, and then .pub is the public key. Now let us push this to the server 2, which is 20.0.0.9. SSH, copy ID, and we would do ID_RSA_1. I believe that's what we have. Let me do ls. Yeah, it is 1. So let's copy paste this command. And as you can see, I'm actually not giving .pub. I'll just say .key, and it will actually send the public key to the remote machine. And then we would do web dev at 20.0.0.9 because that's a remote machine that we are dealing with, and the account is web dev. Hit enter. That failed. It says no such file. Oops, actually it's the file name is not ID underscore, it's my underscore RSA underscore 1.key. That worked. Here is the password, and it is done. Now let me enter SSH of web dev at 20.0.0.9, hit enter, and this goes in with its own key, and it picks up automatically from the .ssh folder. If I exit out of this and do .8, it goes in there as well, but this, let me exit this. When we try to SSH into .8, it uses this public key, and when we go into .9, it uses this public key. So it tries every public key that is found in the .ssh folder and tries to connect. Well, that's it in this video, and I'll see you in the next. Hello everyone, welcome back. In this video, we will look at SSH add command and SSH agent. As before, we will use these 4 machines, and we are on 20.0.0.5 machine, and we will create 2 pairs of public and private keys. We'll use one set for .6 and the other set for .8 and .9, just to demo you the usage of multiple keys and identities and how you can use them. So that kind of gives you a better experience, because that is how it is in the real world. So let us start that. Okay, here are the 4 Linux machines we'll be using: 20.0.0.5, .6.8 and .9. We will be doing our work on .5, and we'll create public and private keys, one for .6, and we'll use a second set for .8 and .9. So that way you will experience using multiple keys to connect to different machines, because that is how it is in the real world. So let us jump in, and let us start creating the keys.
This time I'll be using the password. I mean to say I'll assign a password to the private key. For the first one, I'll use 11111, keep it simple. And I'm going to call it test RSA ID. It's just a name, so it's up to you. So it is done. So it's created. Now I would like to push this to our machine.6. So in order to do that, we'll do SSH copy -i for the identifier. It'll be test RSA ID and training at 20.0.0.6 machine. Hit enter. So say yes for this, and now enter the password. So the file has been successfully copied to the machine 20.0.0.6, and it does say now we can try that. Let's see if that actually works.
Okay, let us SSH training at 20.0.0.6 and hit enter, and it is prompting for the password. And let's see, I mean technically it should be not prompting for the password. So by default SSH looks for a file called ID_RSA, but we have our own name there. We customized the file name. So what we have to do is we need to tell SSH to use that particular file, the one that we want to use, and then try to connect. Now it is prompting for the passphrase for your key. We used 11111. By the way, in production and the real time, you would use some complex password, not as simple as the one that we are using in this video. So it is always recommended to use a strong password. This is only for the demo purposes. I keyed in the password, everything went well. Now next, what we will do is we will, create a set of private and public keys for our .8 and .9 machines. What we will do is I pulled the previous command, and now here I'll change the password to 22222 and I'll call it prod. It is done. Let me list the files, and now what I will do is I'll push this particular public key to .8 and .9, and for that we'll use the same old command, SSH copy and now let us enter the password for the user webdev. Okay, the key has been copied to the .8 machine. Now let us copy it to .9. Okay, we have successfully copied the public key, the second set that we created, to both the machines .8 and .9. Now let us try to connect. SSH webdev at 8. It's asking for the password because as I told or mentioned before, the SSH by default looks for a key with the name RSA_ID. I think it's ID_RSA.pub. So since we are using our custom name, you have to tell SSH to use a specific file and then do webdev at 8. By the way, when you specify identity file by with a -i option with no .pub, it will automatically use it. And it is prompting again,
And that is because we are using the test RSA, because we did not push that. We used prod RSA. So let us change that real quick. Prod, and hit enter. Now it's asking for the passphrase, which is 22222. Hit enter. We are in. Now let us exit out of it. Let us give that a shot with the .9 machine. So we're using the prod RSA ID webdev .9. It's asking for the key 1212. I mean to say 22222. Now we are in. Now let us try to connect to the machine the second time and see if it still prompts for the passphrase. It is still asking. So now, as you can see, now we have created these set of key pairs, and we are using to connect to different machines with different identity files. But however, because these files are password, in real world you will have a password, and every time you connect you're having to enter the password. Now in order to kind of use the password but still not enter the password, that is where the SSH agent comes into the picture. So what that means is there are two commands called SSH add, and also there is something called SSH agent. So what SSH agent does is it will hold these keys and it will use them as your SSH into the remote machine, so you don't have to enter the password once you add it to the agent. And in order to add your key to the agent or identity to the agent, you'll have to use the command SSH add. Now this is the command. First is we need to make sure that the SSH agent is running. If not, you'll have to run it. So first let me check where the agent is, which SSH agent, so you have an idea, it is in user bin. And let us check the process table. So we do have SSH agent. We can also use pgrep. We have two agents running, by the way. We can ideally you will just have one. Let's just go ahead and kill these agents. No such process. Now let me do pgrep SSH agent. Okay, it spawned itself and we have the process running. Now let me do SSH add -l. What this does is it will list all the identities that the agent is holding. So right now there are no agents with, I mean to say no identities with the SSH agent. In order to add that, it's very simple. All you do is SSH add and you need to pass the name of the file. We'll add this one, the test RSA ID. It's asking for the passphrase. I'm done. Now the agent now has this file, test RSA-ID. Now let us try to connect to both a .6 and .8. .6 uses the test RSA ID and .8 uses the prod RSA ID. If I do SSH training at 20.0.0.6, it did not prompt me for the passphrase because our identity file is with the agent. And you can check that using SSH add -l. Now if I try to SSH into webdev at the other machine .8, it will prompt me for the password. Actually this is incorrect. I should be using -i prod. It's asking me for the passphrase. Now in order to mitigate this, we just need to add the prod identity as well. SSH add prod. Enter the password. Done. Now if we do SSH add, we have both the keys registered with the agent. Now when you try to SSH into a machine webdev, what it does is it will, agent will come into the picture in the background and it will,
pass the key to that. So you don't have to specify anything. It directly uses the keys that, the identities that agent is holding, and you don't have to enter the passphrase or anything. So this comes real handy when you're working with multiple servers with multiple identities and all that. And so it generally in real world, you will have a set of private keys for a set of machines based on the classification. So if they're highly critical machines, you have a separate set of key for the test environment. You'll use different set of keys, and for dev, for staging, and for your own infrastructure test machines, you'll have different keys. So SSH agent will come real handy. You don't have to enter the passphrase every time you try to connect to these remote machines. Well, that's it in this video. You know what, before I close it, you can let me show you something else. There's a command called eval. You can also use this to check if your agent is running. Unfortunately I missed it where I was talking about the agent process. You can do eval and check that, or you can do pgrep as I've shown before, which will also give you the process ID and all that. Well, that's it in this video, guys. We looked at pretty much, we went from the beginning. We created the keys, we pushed the keys to the remote machines using SSH copy ID. That means we used keygen, then we used copy ID, and then we used SSH add and SSH agent as well. Well, that's it in this video, guys. This is the last video in this module, and I hope the last video kind of gave you the overview while I was trying to club in the SSH add and SSH agent. Well, that's it. I'll see you in the next video. Hello everyone, we are done with the module. In this module, we looked at these commands: SSH keygen, SSH keyscan, SSH copy ID, SSH add, and SSH agent. If you have any questions, please do contact us. We will respond to you and we'll make sure you understand. And also, there's a document. Please download with the list of all commands, examples, and all that, which will come handy when you work with these commands. Okay? See you later.
Hello everyone, welcome. In this video, we will take a look at the AWS sign-up process. It's very simple. Let's jump in. By the way, we would need a cell phone, a valid credit card number, and a valid email address to complete the sign-up process. Open your favorite browser and go to aws.amazon.com. Click on the Create an AWS Account button on the top right corner. On this page, enter a valid email address, your valid email address. Enter the password twice and give a name for your AWS account. Once you enter all those details, click the Continue button. On this page, click the Personal Radio button at the top and fill in all your personal details: name, phone number, the country, address, city, state, zip code, etc. On the payment information, you will have to enter a valid credit card or debit card number. Make sure you enter the right number and your expiration date as well, and include the cardholder's name there. And you have an option to enter a new address for the credit card, or you could use the one you entered on the contact page, a couple of screens ago. Once you enter all the details, click the Secure Submit button. Here is the phone verification page. You will have to enter the text from the image on the text box below and then click Call Me Now button. Now, Amazon is trying to reach you on that particular phone number that you entered and it displayed a 4-digit code. You will have to answer that phone and enter these 4 numbers. And by the way, it's calling my cell phone. Let me enter those 4 numbers. Okay, I entered those 4 numbers and your identification has been verified successfully. Go ahead and click Continue button. Okay, we are on the support plan page. Of course, we will select the basic plan, which is free by the way. And it does have certain limitations. As long as you're within the limitations and you don't hit those limits, it's completely free to use for about 12 months. Okay. Click the free button. On this page, for the role, pick that's appropriate for you and what you're interested in. Pick whatever suits you and click submit. We are done with the sign up process and now let us sign in into our AWS console. There is a yellow button at the top which is sign into the console. Go ahead and click that. Enter your email address that you used during the sign up process and click next. Enter your password and click sign in button. As a security measure, you'll have to enter the text from the image in the text box provided and click the submit button. Okay, we are now inside our AWS console. Well, in this video, we looked at the AWS sign up process and we have signed in to AWS console. Okay, see you in the next video. Hello everyone, welcome back. In this video, we will create a Linux virtual machine in AWS. So let us jump in. The AWS service that allows users to create virtual machines is called Elastic Compute Cloud EC2. So that's the service we are going to use after we sign into our AWS account or AWS console. Wait a sec, how does this all work? All we did was we signed up for AWS account and now we have the power to create these virtual machines. How does it work? So let us step back for a minute and look at a very high level diagram and understand how this all works. I will not go into the nitty-gritty of the whole networking, but at least I will give you a 10,000 foot overview of the kind of network that was given to you when you signed up for the AWS account. And then we can go into our console and create a Linux machine and then sign in using PuTTY. Okay, let us jump into the diagram now. Okay, here is a diagram and here is a very high level representation of what really happened when you actually open your AWS account. What AWS did is it created a default private cloud for you. A virtual private cloud for you, and it's sitting there ready to be consumed. And the default VPC comes with 3 default subnets, and all the 3 subnets are facing the internet, meaning when you create a virtual computer or EC2 instance within your subnet, it will automatically have a route to the internet and it will get a public IP address. So when you create an EC2 instance now within your account, it gets a public IP and you should be able to sign in using SSH from your machine, from your personal computer. Now, how do we do all that? That's the purpose of this video. We will take a look at it. So now let us jump into our AWS console and kind of look around, look at the router, the subnets, the VPC, and then we will create a Linux EC2 instance. Here is our console, and I clicked on the services on the top, and I will go down to networking and content delivery, and under that there is a VPC. I'll click on it. Here is our VPC dashboard, and this kind of gives you a high level picture of your VPC. It shows you how many VPCs you have, how many subnets you have, routing tables, internet gateways, etc. I'll go ahead and click on the VPC so that I can look at the VPC that was given to me at the time of creation. Here is the VPC. It has an ID which is more internal to the AWS assignment. You cannot change the ID, but you can name it using the name column on the left, and it has an IP address CIDR block of 172.31.0.0/16. Now let us look at the subnets. We have 3 subnets. We have one routing table, and it clearly shows that it has a route to the internet. By the way, the one that you see 0.0.0.0/0, and then you have target as IGW, that's the entry that allows access to the internet. By the way, I hope I was not overwhelming you with all this information. I just wanted to show you what you get with the default VPC when you sign up for an AWS account. Now, let us go ahead and create an EC2 instance now. Okay, I clicked on the services, and then now I have EC2 at the top. I'll go ahead and click on that. Here is the EC2 dashboard, and by default we don't get any running instances. We will have to create them. Go ahead and click on the running instances so you can see the page. Click on the launch instance to start creating a new instance for ourselves. You could have clicked the launch instance on the previous page as well. It's all one and the same. We are on the step 1 now. We will have to choose an Amazon machine image. So here, this would decide the operating system of your EC2 instance. And by the way, we are using the free option, the free tier or the free plan of the AWS. So, you cannot pick any image. You'll have to specifically pick the AMI that is flagged as free tier eligible. If not, you'll be charged. In our case, in this video, I will be choosing the Amazon Linux AMI. Once we select appropriate AMI, the step 2 is to choose the instance type. And the instance type will decide the amount of memory, the amount of processing power, and the network bandwidth. All that is decided by the type of instance that we pick. And by the way, the T2 Micro is a free tier eligible option. So that's the only one that you have. If you try to pick any other instance type, you'll be charged right after you start running the instance. So make sure you pick the one that is labeled as a free tier eligible. Click Configure Instance Details. On this page, you can decide the total number of instances you want to launch, and the VPC by default, it will be the one that we got at the time of sign up. We only have one VPC, by the way. You can always have more than one VPCs in your account. And the subnet in which you want to launch your machine, and there is an option called auto assign public IP, and by default that is enabled on the subnet. So accepting the default options will by default provide a public IP to the instance that we'll be launching. Let's pick a specific subnet, click Add Storage, accept the defaults and click Add Tags. And on this page, you can add tags to your EC2 instance. You can obviously add more than one. And just as an example, I'll add one here. I'll give name as the key and value as SSH server. Click Configure Security Group now. By default, the process or the workflow here will create a new security group, and by default, it allows port 22 for SSH. This security group is equivalent to a firewall on a system. So this is outside the operating system, but it will act like a firewall, like built-in firewall D within a Linux system. But this is outside the Linux operating system, lives within our VPC environment, and it kind of allows the port 22. Accept the default and click Review and Launch. And this is step 7. Review the settings that you picked and click Launch button. Now we are presented with the key pair. Since we don't have any key pair within our account, we will have to create one. Use the drop down there and select Create New Key Pair. Give a name to your key pair and then click the Download Key Pair to download the key to your machine. By the way, you would need this key to SSH into this particular EC2 instance. Go ahead and click Launch Instance. Okay, AWS finished launching the instance. Click the View Instances button. Okay, here is the instance that is still being launched by the AWS environment, and it's as you can see, the state is pending. So it may take a few minutes for AWS to fully launch your EC2 instance and make it operational. Okay, the status has changed to running, and the status checks are still in the initializing state. But we should be good to go. We should be able to SSH into the system most likely. Okay, let us try that now. By the way, the Actions drop-down button will allow you to, stop an instance, start an instance, or terminate an instance. When you say terminate, it's completely gone. Amazon will completely delete from your account. The very first option in the drop-down is Connect. It does not connect to the EC2 instance, but it will show you the command that can be used to connect to the instance. Here is the SSH command, and it is using -i option to use the private key to connect to the EC2 instance. Now the interesting thing is there's nothing we did in terms of public IP. The AWS environment assigned a public IP to you, and moreover it is DNS name, not just the IP. If you look at the command there, it says EC2-18- blah blah blah, and then it says .compute.amazon.aws.com. It's not IP address, it is a DNS name. You can also use the IP address from the console and use IP address to connect it as well. Both will work. So let us do it. Okay, here is the public IP. I'll make a copy of it. Now let us switch to our Windows machine and try to SSH into our AWS EC2 instance. To start with a PuTTY, we will be needing PuTTY key generator to, generate or extract the PuTTY private key from the key that we downloaded. So go ahead and start the PuTTY key generator and load the .pem file that we downloaded from AWS. Once you load, you have an option to save the public key and the private key. I will go ahead and save both the keys. Now that I have the private key and also the public IP address of the EC2 instance that we created, I should be good to go with the PuTTY now. I'll just go ahead and create a profile. And by the way, the user that we should be using is EC2-user. So let me go ahead and configure a PuTTY profile with the username EC2-user and the public IP address, and also I'll configure the profile to use the private key. Okay, I created the profile, saved it. Let me, click the open button. I have a PuTTY security alert here. I'll click S. And we are in. I did not enter any password. So the system, the PuTTY, used the private key and SSH into our EC2 instance. Let me switch to the AWS console and show you the SSH command that AWS displays there. As you can see, it says SSH space -i, the private key, file name, and then EC2-user at the DNS name. Let us try using this command. I'm going to use MobaXterm, which is freely available on the internet. You can go ahead and download it and install it on your Windows machine. This particular tool comes with built-in SSH tools. It also comes with SSH server, but I'll not get into all those details. But if once you install, you can open a local terminal which would emulate a Unix-like environment, and it already has SSH as a command built in, which you can use to connect to the EC2 instance. Okay, here is my local terminal session, and I'll cd to the folder where I have the .pem file. Let me change the permissions to 400 on all the .pem files, and then what I'll do is I'll try to connect to our EC2 instance using the command provided by AWS console. I'll just copy paste the command and try to connect. As you can see, we are in. The Linux machine is all yours to explore and learn. Okay. In this video, we looked at the default VPC and the default subnets that were provided. And then we created an EC2 instance using a Linux image and also the free instance type. And then what we did was, during the instance creation process, we created a key pair. We downloaded it. And then to make it work with PuTTY, we loaded it using the PuTTY key generator and extracted the public key and the private key, which is .ppk for PuTTY private key, and then used it using PuTTY to connect it to the EC2 instance. And then we used MobaXterm to connect to our EC2 instance using the command provided by AWS. By the way, the same command can be used on any Linux machine or a Cygwin environment to connect to this particular EC2 instance. Well, that's it in this video.